right, let me get set up here. We were talking about math expression definitions in this video. We are doing some more definitions, and what this is going to allow us to do is to simplify expressions and convert from word problems, because word problems are always pretty challenging for kids, for students. They were challenging for me. So as you're writing these down, what again I would ask you to do is to wait until I'm done speaking at the bottom of the slide, and then pause your computer and write down what you see, because it is really challenging to listen and write at the same time. And it doesn't take that much more time for you to listen to the whole slide and then copy it down. Just a couple more minutes. So it's really worth it. So let's get started. The first two terms that we have are total and increased by. Increased by and total, they both talk about addition. Okay, so let's look at an example. In the first one, it says the total of 5 and a number x. Well, total tells us that we're going to add, and we're going to add 5 and a number x. So 5 plus x. Increased by, let's look at an example for an increased by. So it says 15 increased by 6. So as soon as you see increased by, you know that we are going to add, so it would be 15 plus 6. Up here it says terms do not flip. So whenever you see the word total and whenever you see increased by, what do not flip means is the 5 came first in the verbal expression, so it came first in our mathematical expression over here. The x came second, so it would go second. Likewise with increased by, the 15 was first, the 6 was second in the verbal expression. So the 15 comes first and the 6 is second in the numerical, or excuse me, in the mathematical expression. Again, the 15 plus 6, this from our notes from the other day, that is a numerical expression because it just has numbers. The 5 plus the x, that is a variable expression because it has the variable of x. So let's move on to the next slide and pause your computer or go back, and if you need to, pause it and write down those definitions and examples. So in these terms, we have difference and we have decreased by. Both of these, you can see up here, are subtraction. So the difference between 15 and 3, the difference between 15 and 3 means that we're going to subtract. So 15 minus 3. Decreased by is a number m decreased by 60. So a number m decreased by 60 would be m minus 60. And again, up here it says do not flip. So the words difference and decreased by, we are going to know that we are using subtraction, and we are going to mirror or mimic the location of the values where they are in the expression. What I mean by that, if the 15 comes first and the 3 comes second, that's how we plug them in. That's not going to be the way it is for all expressions. So total, increased by, difference, and decreased by, these are all words that you do not flip. You do not flip the terms. Got a little fancy artwork on there. Another one. All right. So for these are our next set. We have 3 terms: more than, greater than, and added to. Again, all using addition. And let's go over some examples. 6 more than 12. Well, if we have 6 more than 12, what number are we starting with? We're actually starting with 12. And if we have 6 more than that, we would add them together. So it is 12 plus 6. This is a little bit different from the previous 2 slides in that, if you'll notice, the 6 was first and the 12 was second, but in our expression, we flipped them. And again, it says up here that we are going to flip these 3. Greater than, 10 greater than V. So what are we starting with? Are we starting with 10 or are we starting with V? 10 greater than V? Well, it's in that one, we're starting with V and we're going V plus 10. And then the last one, added to, 12 added to a number T. Which one are we starting with? In that one, we're starting with T and we're adding 12 to it. So T plus 12. So in this one is a numerical expression, 12 plus 6. you can simplify that to 18. In the second one, it is a numerical expression. V is our variable. Excuse me, it's a variable expression. V is our variable, and our positive 10 is our constant. This has a coefficient of 1, just because it's 1V. And then in the last one, this is another variable expression. It's got a variable of t. It's got a constant of positive 12 and a coefficient of positive 1. So I'm going to try and include all of the different lessons that we've been learning up to this point. In the last slide, I believe, or one of the last ones, we have fewer than, less than, and subtracted from. These terms we are going to flip, and they are using subtraction. So let's look at some examples. 12 fewer than 18. Well, if we're going 12 fewer than 18, what is 12 fewer than 18? It really is 18 minus 12, because we're starting with 18 and we want what is 12 less than that. So down to 6. Less than, 5 less than a number y. Again, we are starting with y and we are taking 5 away from it. So that would be one where we flipped. Again, the 5 was the first term in this verbal expression. Y was the second, and we're going to flip them there. Subtracted from, 16 subtracted from 25. 16 subtracted from 25 means that we're actually starting with 25, and we're taking 16 away from it. So it'd be 25 minus 16, which would give us 9. Now, in this case, we've got two numerical expressions. The third one, 25 plus or minus 16, and the first one, 18 minus 12. And then we've got one variable expression. The variable is y. The constant is -5. The coefficient would be 1. These would have two constants in them. Numerical expressions only have constants. Okay, so for these words, more than, greater than, added to, fewer than, less than, subtracted from, we flip them in the expression. Summation symbols. These are is equal to, is greater than. And you see the word is here. Whenever you see is, that means that we're dealing with equals or summation symbols, meaning equals, greater than, is equal to, is greater than or equal to, there, is less than, is less than or equal to, and then quantity. Whenever you see the quantity of something, that means you're going to put them in parentheses. Okay, so these are the summation symbols, and the one thing that all of our summation symbols have in common is that they have is in common. And there are going to be a few more, but these are the beginning stages of what we are learning. So make sure you get these words down, make sure they're neat, and we're going to refer back to them in the lessons and practice that comes up. Okay, have a great day, and look forward to answering any and all questions that you have for me. Let's get